Welcome back to AIM Chemistry, Learn Chemistry with Dr. Poonam. Student, calculation of pH for strong bases. So similarly like that, how we calculated for strong acids, strong alkalis are also completely dissociated in water. So when they are completely dissociated, so if I have a concentration of NaOH, if it is given, then it is equal to concentration of hydroxyl ion or any base. It is a potassium hydroxide or any base, so that concentration is taken as a concentration of hydroxyl ion. So to calculate these, students, here we use two simple formulas to calculate pH of strong bases. Actually this is calculated by two different methods, method 1 and method 2. So in method 1, directly we need to use a formula like a pH, that is POH. The formula will be POH, similar formula, negative logarithm to the base 10, and concentration of hydroxyl ion. And in method 2, we need to use ionic product of water. Ionic product of water means it's a dissociation constant, or we call autoionization constant. We will discuss in detail. So that is Kw. So both methods are applicable, but generally in bilingual syllabus they provide ionic product of water, and from that ionic product we need to calculate pH or concentration of hydroxyl ions. But student, for our sake of convenience, we will discuss both methods. So first we will discuss this method, that is method 1, by using formula POH is equal to negative logarithm 10 to the concentration of hydroxyl ion. So student, here we use this formula as well as we need to use second formula, that is, as we know that pH plus POH, concentration of hydroxyl ion and concentration of OH minus ion at 25 degrees Celsius. At 25 degrees Celsius is equal to 14. So by using these two formulas, you can note down these formulas. By using these two formulas, this is your method 1, we can easily calculate pH of alkalis. We will take simple one example. Calculate the pH of solution of sodium hydroxide of concentration 0.05 mole per dm cube. So student, see, here we need to, as I already told you, that we need to use two different formulas here. The number 1 formula we will use POH is equal to negative log 10 concentration of hydroxyl ion. Now here we have provided with the sodium hydroxide concentration. So as I already told you that when there is the concentration and strong base is provided, that means it is completely dissociated in water. So complete dissociation or complete ionization means concentration of base given, like similarly like acid, concentration of base given is equal to concentration of hydroxyl ion. So these concentrations are equal. So the concentration of sodium hydroxide is provided, that is 0.05. So this is the concentration of OH minus. So we need to put this value POH is equal to negative log 10, concentration is equal to 0.05. So now by using calculator we can calculate students, take pause and calculate. So its POH is equal to 1.30. But we need to calculate pH. We do not have to stop at POH. So here we will use second formula, that is pH plus POH is equal to 14. Keep this value of POH in box. So how you will calculate? By this formula, now you have value of POH and this 14. So pH is equal to 14 minus POH. So 14 minus 1.30. Keep your calculators ready, students, always. So 14 minus 1.3, it is equal to 12.69. In this way, students, we calculate pH of strong base when concentration of concentration of base is directly given or concentration of hydroxyl ion is given. So now I already spoke about method 2, that is ionic product of water. We can calculate pH of base, strong base, from ionic product of water. But student, for this we need to understand what is the meaning of ionic product of water.